bear with me. And I want to be fair to everybody lah, like I say, later on, the sitting now is fine. Later on, second half of the lesson, we will split into groups for your assignment 2. Okay? So you all can do it in groups. So I will do a very quick recap of what we have done last week first. Remember what we talked about last week, right? What is finite element? Finite element at the end of the day is if you have something very regular, you can do it by hand using a Bernoulli equation, using standard formulation, no problem. But when it comes to something, especially when it comes to geometry, okay, then you need to do what? You need to discretize it. And we say, you see, if you look into this is what we call a finite element mesh, correct? If you look into the individual elements, they have a fairly regular structure, correct? So it's to discretize it into something that is regular, okay? And we talk about the finite element that uses a single format, something called as a shape function. Okay, but in our case, we are not going to go to this type of derivation. So we are going to something less intense, known as the stiffness matrix. Okay, the direct stiffness method. So basically, I'll go back to it again. And we talk about this. People will ask, when you come to your finite element, what is the when you come to finite element, what sort of model can you use? I just want to repeat again. When it comes to finite element, actually you can solve for different type of issues. Be it your heat transfer, elastic, fluid, electrostatic. Now there's a lot of multi-physics thing going on also with finite element. Okay, so the geometry is one thing. It doesn't mean that you only do your stress and strain. No, it does a lot of different types, all dependent on your governing equation. You can fit different governing equation to the same model. Okay. And we go back to this again. Just want to have a quick, very quick recap. Remember we talked about the end of the day, right? Actually, it's nothing complicated. Last week we tried it. It looked very complicated when you have a lot of springs involved in one model, correct? But actually, it's not difficult. Why? Because it's all based on one spring element, correct? So once again, get the first spring element correct. There's no difficulty in solving this at all. Agree? Yes. So that is to let you have a flavor of what a finite element look like. The model could be very complicated, but you solve it from an individual element perspective. It's actually very simple, correct? So you just remember how we build our first model, our first element. Okay, the first element will be the k minus k minus k, u1, u1, u2. We talk about this, right? So what does this mean? This means that in order for me to, the force for me to exert, if u2 equal to 0, what is the force I need to push it in? Alright, it will be what? The F1 will be equals to K multiplied by U1. U1 multiplied by K, so U1 multiplied by K. Alright, that's the force I need if I'm restricting this end of the spring and then pushing this in. Alright. Flip side, what is the reaction force that's coming up from here? With K multiplied by U1. Alright? On the F2 side. Right. Okay. So after we get this, you got a standard spring matrix. You got a standard stiffness matrix. We can assemble them. Remember, the assemble them is also nothing difficult. This is your first spring. This is your second spring. Put them together. No matter how complicated, it could be done. Right. It's a matter of what notation. That's why we say that it's important for us to notate. Remember, we said everything as an engineer will always come in with a figure, correct? So we need to note down what is our degree of freedom. U1, F1, U2, F2, alright? And you have your element, which represent your stiffness, K1. Okay? And no matter how complicated it is, you can assemble it. So we went on to also talk about the assignment 1. We solved for this assignment 1, correct? Remember we talked about this. Essentially, this have one degree of freedom, U1, F1, correct? U2, F2. Okay? And we build out the stiffness matrix. when we talk about this, it's the negative force, correct? Even though it's moving right to left, then it just means that when it comes to F1, F2, F3, F3 is a negative n times 10 to the power of 4. Next, we talk about this, correct? Now it looks more practical, but actually it's actually the same thing. Each of these represents a spring element. What is the stiffness? Class, what's the stiffness? What is your K in this case? Very, very good. EA over L. So essentially, because we are talking about a translational degree of freedom, correct? So it's your spring compression and tension. So it will be EA over L, correct?
Sorry, can I ask one question about the reaction, right? So just now in the slides you show, right, at node 1, right, it's K1 U1 minus U2. But why in?
You are talking about this?
Yeah, this one. Yeah, but so in the other case where the reaction should be at node 1, right? At that question.
Which one?
Okay, so based on this, right, it's
Yep.
F1 is equals to K U1 minus U2. Right? So reaction is also should be the force at spring on node 1, right?
Yeah, this is all internal force, so the reaction force is always outside.
Always outside.
The reaction force is always outside.
Okay. Never mind, I digest first.
Yeah. So you imagine all these internal force. So imagine if I was to pull this force.
Yeah.
Correct.
Yeah.
What would be my reaction force?
Reaction force.
Here, correct. Because the your internal force and the external force
Should be
add up
equal.
equal to what?
0.
0. So this is a vectorial force. Correct. So you must add up in the vectorial form. So it's 1 positive, 1 negative, add up to 0. But it's a good. You just imagine if you pull this side, right? So what is the force you need to restrain? You must exert the force in the opposite direction in order for you. So that would be your reaction force.
Okay.
Yeah. Okay, let's go on to the next question. So we will end 5:30 today, right? So we have about 1 hour to do this first part. Today, good point. Let me go on first. So today what we are doing, we're going to spend the first 1 hour we're going to first spend the first 1 hour, right, doing the rest of the assignment 1. Then the second hour, I will go through very, very quickly on what is abacus to give you a flavor. Okay? The third hour, right, I want to spend is to form you all into groups, and I want you to look at assignment 2. Okay, I want you all to spend some time to look at assignment 2 so that you all have a rough idea. The point is I want to start you to think about it over the weekend. Okay, because we've got 2 weeks, right? We got 2 weeks. I will not see you for 2 weeks. So you have this coming weekend, which is today, tomorrow, and you have the Chinese New Year weekend, correct? So you all can do something. We should do assignment 2, so that you all have more time. I want you all to start to think, what is the question asking from you? This is all about application. We learn all these things, you will see the way that RMIT, which I think is actually very, very good. So you have an idea, why am I doing this, So how do you apply finite element in things like this, okay? Okay, you got 10 minutes, read the question, know what you want, draw your diagram, build out a sticker matrix, 10 minutes.
Huh?
This is
Oh, it's like Aftershock. Yeah, it's the same OEM but just different brand.
gaming laptop, is it?
Yeah.
Read the question.
So maybe Thursday instead of this call. Stress, I don't know the stress got one or two. 我们的 question stress one 有一个还是两个？
我不懂诶，based on 他那时候他是讲，他只是写一个 equation 而已，所以我那时候也是没有想太多，我 just 做而已。然后等一下我们可以问他。
我看到是两个墙，
两个 material 这样吗？应该100 right？logically 要有两个，but 我 question 他也没有写得太清楚。
Hey class, if you got some calculation error, some calculation error is supposed to be 210, you put 206 or 207, I confirm give you one, okay? If I mark wrong like that, everybody will fail, okay? And that's why I told you it's very simple for me. You know, whenever I get your exam script, I will make sure I have your pass also. First thing I look for is what? I check your diagram. If you have a diagram, 10%. If you rotate, 10%. If you give me the same matrix, 20%. You know, so if you calculate from the matrix, you inverse, you calculate 50%. Right or wrong, 50%. Right or wrong, 50%. If you do it in this step, calculation error in the middle, I don't care. You will be 50% like that. Of course, because the full mark, your calculation must be correct. But even if you're 10% off the top of it, I don't care. Because you're using Excel sheet to calculate, then you will have calculation, that type of thing, you know. Yeah. Final element, rule of thumb, you get exact figure. No, you don't. Most of the time, for different reasons. Okay, 10% is industry norm. If it doesn't answer the question, make sure you calculate correct. No talent, you know how you go check through. But it shouldn't be that hard, to be honest. Yep. No, it doesn't matter. Hey class, another thing, very good question. To me, if you give me in meter or you give me in millimeter, I don't care. I'm okay with it because that is later on later in the that's why because now you are not doing a practical problem. When you go into a practical problem, you know why you should do in millimeter or meter. But in it's okay for me. It doesn't matter because we need to be very attuned to using the different unit, whether it's meter, millimeter, Pascal, kilopascal, megapascal. You should be very attuned to it, you know. So it's like, for example, let's say if you are doing with steel material type of thing, normally we do in megapascal. When you do it in soil, that type of thing, you do it in kilopascal. It's an industry norm, but in general, it's fine. It doesn't matter. So you all don't need to worry about this one. Important is you put in your unit. That is important. So you have a lot of zero, then you know that you should do another one, but I will not do that for that. I will not. It's me making it difficult for yourself. To me, so don't worry about that. No worries. So long as you can illustrate to me, you understand the problem. You want to try?
Oh, it's Type C, is it?
But I think it will.
Huh?
I think it will.
Oh, iPhone only. Type C, I have. I thought now the iPhone Type C.
Yeah, it's
Or 50.
It's very good. I saw a lot of people have done your first few questions. I think it's a good sign. Hey, is it? Can you see well? Is it clear enough? I thought it looked very foggy. Now why? Seriously? Is it better?
I don't know what's K in this case. Don't know the T, is it the thickness of the pipe or thickness of the outer inner?
He might. You never experienced that. Length tightly fitted around the shaft.
What's DSM?
Monday. Sorry? What's T1, T2? Ah, very good. What T1, T2? N lah, same thing lah. What is N?
I mean, where is the T1? Is it the thickness of the...
Correct. Very good question. Correct. Thickness of one of the element, then the other thickness the other element. This time around they write like that.
Then what is DSM?
Sorry? Okay, what is DSM? This thing that we are doing is called the direct stiffness matrix. Oh yeah, now I remember. There is a learning guide inside your Canvas. Actually, we didn't go into Canvas that much, so later I will orientate you into Canvas also. I thought I should do that. Yeah. But let's finish this one first. T1, T2 doesn't really matter because T1 will be together with E1, T2 will be equal to E2, you know. Then your L1 will be same for both lah. So it is the because this is the composite pipe, correct? So it have two material. Yeah. So yeah. So T1 will be the inner one, T2 will be the outer one. Yeah, correct. So okay, T1 will be the inner, T1 will be the outer pipe, T2 will be the inner pipe.
Wow, 像那个 area.
对啊
Area of circle.
Yeah, correct. It's the at the end of the day, it's the area.
area of circle. Radius is 6. Height 是 L1. M12 bolt 它的那个 bolt 是12 diameter 12 then radius 是 6 它是 machine bolt 是不是那个这个东西哪？这个是哪？M12 12，百米都是11了吧？可以算12。
Good. Later you drop, but it's a good
Huh?
study. Good. Later you
I
drop.
don't know.
No, it's okay. Later you drop. But it's good, it's good. It's good, it's good. It is good. I will not suffer you so you don't worry.
Give more marks.
Sorry? Quickly draw out your string, all these things, then later you go out and draw. It's a good thing.
要慢慢来。
Like last time they used to give the area directly. This year around they write it slightly different. No wonder.
Yes.
Then what's a K? Now you are using that's a K. Then what's a K?
K equals to area of cylinder P over then C pi
Correct.
R square H. K1 是
所以这现在不是 R correct，因为你要 minus because it's the
它是12 divided by
不是because it's M12 volt
M12,
correct.
yeah.
But imagine so imagine you have like this one correct. This is
Yeah.
imagine this is an M12 volt correct.
Yeah, correct.
This is an M12 volt. And this thickness 是多少 okay, this thickness 是 N. Then you have outer thickness. Oh, sorry, this thickness is the smaller one. So this one should be 0.75.
Oh, there's two elements
This one
inside.
N, correct, correct. So it's a composite It's a composite type. So it's 0.75 N is N. 所以你的一个跟里面的这个。
Oh, this black color is one element. This 外面是 one element. Oh.
讲完了，够。
Do not be discouraged by this. The whole point, if you realize I will always let you do it first. Because you must understand when it comes to IMIT, you already know whatever you learn is the first correct. But you must be confident to apply it. It's a further down show. Okay? You must be ready to think about it. Like what you do, you draw it out, then you find out what is your problem that you do. What's your K? You know what's your K. K is just already said EA over L. So what is the thing that you do not know? You must be willing to try. Because in the exam, you need savings and this. Okay, you don't really need, as you go down the lesson, you will realize There's a lot of this sort of thing going on that you need to be able to, you must be willing to just try. Okay, you must put your thoughts